Hi students, in this video we will be going over the volume of 3D figures. Our essential question for today is, how is the volume of 3D figures calculated? So how is the volume of 3D figures calculated? And again, the main purpose of the set of notes is to go over volume of 3D figures, which is a little bit different than area because we're talking about 3 dimensions, whereas before we were talking about 2-dimensional figures. So the first one that we're going to go over is rectangular prisms. And to find the volume of rectangular prisms means that you're finding all of the volume of everything inside of the rectangle. So all the space inside of that rectangle, how much is that? And so that's a little bit different than area because with area it was a flat plane surface, whereas with volume it's a 3-dimensional object or figure. And for rectangular prisms, I know that we've gone over this a little bit during this year, but that is simply using the formula length times width times height. And the length is going to be the 5, okay? And the width would be the 3, because if you think about this, right here is basically all this area right there that's just a rectangle. So you're basically finding the area of that rectangle and then multiplying it by the height, which is 6. So you're just finding the area of one of those rectangles and then multiplying it by the height, which is where we get length times width times height. So we multiply those three sides, those 3 dimensions together, and we get 90, which means that the volume of our rectangular prism is 90 feet cubed. And remember, this is going to be cubed now rather than squared because we're talking about 3 dimensions. When we are talking about area, that's just 2 dimensions, length and width, which is why it's to the second power or squared. But now we're talking about 3, length, width, and height, which is why it's cubed. Now there are a couple of practice problems just one practice problem on your foldable, so take a second and try that problem. All right, the next one that we're going to talk about is a right triangular prism. A right triangular prism. And in this one, basically you're doing the same thing as we did before, and you're finding the area of the base and multiplying it by the height. Now many people end up thinking that the base is the edge that it's sitting on. However, you need to ask yourself, what kind of problem is this? It has to deal with triangles, okay? So it has to deal with triangles. And so if we have to use triangles, then we know that the base is going to have to be a triangle as well. So when we look at this problem, we know that this triangle right here and all this area is going to be the base, okay? So it's basically telling you find the area of the triangle and multiply it by the height. And if you remember, oh, and one more thing, sometimes you'll see the volume of a triangular prism written as a capital B times the height, and that's just saying the area of the base multiplied by the height. But the first thing that we need to do is find the area of the triangle, okay? And so if you think back to 6.1, we talked about this, and the area of a triangle was 1/2 the base times the height. Now the base in just the triangle, because we're focusing only on the base of this entire figure, is going to be either 3 or 4. It doesn't really matter because multiplication is commutative, and that means that whatever order you multiply in, you would get the same answers. And so we've got 1/2, 3 times 4, and 3 times 4 is 12, and half of that is 6. So that means the area of this triangle is 6. Now once we've found that, we can find the volume by multiplying it by the height. Now the height is going to be right here, and so that is that distance from one end of the triangle to the other triangle. And when I multiply the base, I get 6, and the height 11, I end up with 66, which tells me that our volume of the triangular prism is going to be 66 centimeters cubed. Now there is a practice problem to try in your foldable, so try example number 2. All right, so this one is a pyramid. So we're going to be finding the volume of a pyramid. And as you can see, the base of a pyramid is always going to be square or rectangle. In this case, it's rectangle because even though it looks square, the length and the width are not the same. And so it has to be a rectangle. And so since this is pretty similar to a rectangular prism, we use a formula very similar to that, except we divide it by 3, because a pyramid is only a third of a rectangular prism. And then from there, you just plug in your numbers. So the length and the width are going to be in the base of the pyramid. So this would be the length and the width. And again, it really doesn't matter which one's the length and the width, because multiplication is commutative. So whatever order that you multiply in, you'll get the same answer. And the height, this is very important. The height is always the thing that forms a 90-degree angle. So you can see that from the top of the pyramid down to the base of the pyramid, this forms a 90-degree angle. And this 90-degree angle tells us that this is going to be our height. So we simply multiply together 10, 8, and 6, and divide it by 3. And when we multiply all those numbers together, we get 480, and we divide that by 3, which gives us 160. So the volume of the pyramid would be, and that would actually be in inches, but I just didn't write the right thing, would be 160 inches cubed. So 160 inches cubed. Now there are a couple of practice problems on this one, so examples 3 through number 4 that you can try on your foldable. All right, now we're going to start getting into more circular figures, and when we go through these ones, we're going to have to use pi to help us solve these problems. Now the volume of the cylinder, if you look at a volume of a cylinder, what's very interesting about this is it's very close to being a circle. And so if I look at just this part up here, this is basically a circle, right? I know it looks kind of like it's an oval, but it's really not. It's just the way that the figures have to be drawn to be shown on paper. But if you think about our previous problems with the rectangular and triangular prism, our goal is always to find the area of that base and then multiply it by the height. So when it was a rectangle, we found the area of a rectangle and multiplied it by the height. When it was a triangular or a right triangular prism, we found the area of the triangle and then multiplied it by the height. But it's a little bit different with pyramids, so that's a whole different thing. So the same idea, though, goes with cylinders, is that we have to find the area of the circle and multiply it by the height. So the formula for this, then, is volume equals pi r squared times the height. Now, remember, the formula for finding the area of a circle is just pi r squared. And this makes sense that now we multiply it by the height, because that's going to give us our depth of that cylinder, because it's basically a circle all the way through the cylinder. Like if you were to cut this circle in half, or the cylinder in half, you would have circles still on the base. And so that is why we multiply that by the height. Now from here, we just plug in the numbers that we need. In this case, we know that pi is 3.14. Now the radius, they actually did give us the radius rather than the diameter, which is 4. And our height is something that forms a 90-degree angle. And so there is a 90-degree angle from the top of the cylinder to the bottom of the cylinder. And so we simply plug in all those numbers. Now it is very important here that you use the correct order of operations, much like we did in the previous section when we were talking about circles. Because it's really important that you do exponents first before you multiply anything else, because if you don't, you're going to get the problem wrong. So the first thing we need to do is 4 to the second power, which is 16. And at this point, you can multiply again in any order that you want, because multiplication is commutative. And it doesn't matter which order you multiply in, you're going to get the same answer. So I usually tend to try to work with all the whole numbers first and then multiply by pi, because then that's when I start getting decimals. So in this case, I multiplied 16 by 6 first, and that gives me 96. And when I multiply those together, I get 301.44. And so our volume is 301.44 feet cubed. Now it's very important that you read carefully on your homework and quizzes, because sometimes they ask you to round to either the tenths or the hundredths. So you need to make sure that you're looking very carefully at what it is asking you to round to so that you get the correct answer. Now we have a couple of practice problems on cylinder, so take a few minutes and try these problems. And now we're going to talk about, and that says cylinder, but it's actually a cone. So we can just cross that out and we'll point up to a cone, but you get the idea. Okay, so find the volume of the cone. Now, if you look at this, this is very similar to It kind of is similar to a pyramid when you think about it. And when we had a pyramid, we knew that the base of it looked like a rectangular prism, but that the pyramid was 1/3 of that. Now, the question is, what figure does this one resemble? This really almost resembles our cylinder from the previous problem. And so if you think about our formula for cylinder, we're going to use that, and just like we did with the pyramid, we're going to take 1/3 of that to get the volume of a cone. Okay, so very similar to what we did with the pyramid, we're taking that formula and we're basically cutting in 1/3. And one thing you could do when you're doing 1/3, you could just divide by 3 at the end. So that is an option of what you could do as well. All right, so then from here we just start plugging in our numbers. So we know that pi is 3.14. We can see right here that the radius is 3, so we plug that in. And the height, which forms a 90-degree angle, is 8. Now again, it's important that we multiply or do our exponent first. And so we get 9 where there was 3 squared. And then I'm just going to start multiplying some of these numbers together that are simple to make our life a lot easier. And so 9 times 8 is 72, rather than starting with a 3.14 and multiplying there. And then when I multiply this together, I end up getting 226.08. Or one thing you could have done also is you could have even divided, say, just the 72 by 3, or done 1/3 of 72 early on. Because again, multiplication is commutative, so it doesn't matter what order you multiply because you're going to get the same answer. And when I divide 226 by 3, or if I multiply it by 1/3, I end up getting 75.36. And so that means our volume of the cone is 75.36 feet cubed. So we have a couple practice problems on cones, so take a few minutes and try these problems. And our last three-dimensional figure is a sphere. And the sphere is a very different formula, and it's one that you haven't seen so far, because in a sphere you don't have a height, you just have a radius or a diameter. And our formula for the volume of a sphere is 4/3 pi r cubed. So that's a little bit different than before as well, because we're talking about something cubed. And so what we do from here is we just start plugging in those numbers that we see. So we know pi is 3.14, and we can see that the radius is 9. Now again, it's important that you follow order of operations and that you do 9 to the 3rd first, which gives you 729. And if you're thinking throughout this video, oh my goodness, can I use a calculator? Of course, please use a calculator. I don't want you to get bogged down with the calculations. I want to see that you understand how to use the formula. So using calculator will be very helpful. And now I multiply 3.14 times 729, which gives me a gigantic number, which again is why a calculator will be very useful. And when you do 4/3 times 2 over 289.06, that's a very terrible number. One thing you could do is you could turn it into a decimal and multiply, but it might make it off a little bit. But my suggestion is multiply it by 4, okay, so the numerator, and divide it by 3. So one more time, the easiest way to do this and the best way to make sure you get the correct answer and you have no rounding errors is to multiply your number by 4 and then divide it by 3. And so when I do that, I get the volume is 3052.08. And one kind of helpful hint to make sure that you're getting this problem right is that when you are doing this, if the answer that you get is slightly bigger than the one that you had right before that was in parentheses, then you know you're on the right track. It shouldn't be smaller because 4/3 is greater than 1, which is going to make that number become larger. And so then our volume of a sphere is 3052.08 centimeters cubed. And we've got 2 last problems to try on your foldable. So take a few minutes and solve those. And again, you can use a calculator to help you with the calculations. If you have any questions, please let me know.